Hi everyone, and here we're going to do a few more examples about the chain rule for differentiating compositions of functions. And let's take a look at number 13. And that one is a little bit unusual because you have the outside function of the square power, the second power, the middle level function, the sine function, but the innermost function of 3x. So we have quantity sine of 3x all together to the second power. So how do we find the derivative? So let's begin with our general rule for the chain rule. So start by differentiating the outside function. So I bring the 2 down, leaving sine 3x untouched to the first power, and then times the derivative of the inside, which is going to be, okay, let me do that in 2 steps. I'm just going to write here. I'm going to next find the derivative of sine of 3x. And let me finish in the next step. So first part I will write again as it is, 2 sine of 3x. Okay, what is the derivative of sine of 3x? So the outside function is sine, the inside function is 3x. So that one will be cosine of 3x. First we take the derivative of the outside function times the derivative of the inside, which is 3. So in summary, multiplying the 2 and the 3 together and bringing it up front, we can leave our answer like this: 6 times sine of 3x times cosine of 3x. Okay, what about number 12? Another one involving a trigonometric function. Here we have cosine of the cube root of quantity x squared plus 1. Let me begin by writing the cube root as the 1/3 power. And notice this time, the 1/3 power is not on the outside of everything. It's not like over here when we have power of 2 that applies to everything. The power of 1/3 only applies on the inner quantity, so it's a little bit different. So what we have here is cosine of quantity x squared plus 1 all together to the power of 1/3. But we do have a clear outside function here, and it's not the power function, right? The outside function here is the cosine function, because the 1/3 power is not on the entire cosine of the quantity, right? That's why. So let's begin by taking the derivative of the outside function. So negative sine of, leaving inside the same, x squared plus 1 to the power of 1/3. And now let's multiply that by the derivative of the inside. And the inside is, of course, the x squared plus 1 to the 1/3 portion. Now there we can apply the power rule, right? So here's going to be 1/3 times x squared plus 1, subtract 1 from the power now, so it'll be negative 2/3, times the derivative of the inside of, which is the derivative of x squared plus 1, and that is 2x. So these last few examples were a little bit more challenging. The main reason being you have, in a sense, 3 types of functions. You have the outside, you have the middle layer, and you have the inside, the innermost. So then what we do in those situations is first we do the outside, and then we say, okay, next we're going to take the derivative of the middle, the inner 2 layers, and then that you can do in a separate step. Like it might be a bit easier if you break it down like I did in the previous problem, where you say, okay, you put your intention, and next I'm going to take the derivative of this portion, and then you go ahead and do that. That breaks the problem into smaller parts, and it may make it a little bit easier for you. So this one I still have to simplify. So here I have negative 2x sine of x squared plus 1 to the 1/3 all over 3 times quantity x squared plus 1 to the power of 2/3. So all I did there was just take the one with the negative exponent and bring it to the denominator, and then combining the constants or pull to the front the 2x, the negative 2x, and leave everything with the positive exponent in the numerator. Okay, so chain rule can be a bit tedious, but really it's a culmination of all the rules you have learned. So in a way, like if you do well in chain rule, like you are on the top of everything else in terms of derivative rules from the previous sections, because here not only you need to know them, but you're using them in different combinations. What about something like number 11a? It's unusual, once again, because we don't have like a clear power on the outside of everything. So when you look at this, First and foremost, what do you see? So I'm thinking like a product, right? X squared times quantity x cubed plus 1 to the 4th. So it's a product. So I'm going to begin with the product rule for this example. Now, if I had everything to the power of 4, I would begin with the power rule, but we don't have that situation. So we have a product. And within the product rule, when it's time to take the derivative of the second factor, that's where the chain rule will kick in. Okay, so let's begin using the product rule. The derivative equals, so I write the first one as this, times the derivative of the second quantity. That's 4 times x cubed plus 1 to the 3rd. And what am I missing here? If you said times 3x squared, you are correct. That's the derivative of the inside of the second quantity. Plus, write the second one as it is, times the derivative of the first, and that will be 2x. And one could simplify this a little bit, like you can look at it as this as your first term, separate with a plus sign, this as a second term, and you could see what is in common to both. Like for example, x is being repeated, right? And also x cubed plus 1 to the 3rd is being repeated. And even a 2, a factor of 2. So I could take out a 2x and then x cubed plus 1 to the 3rd and see what's left behind from the first group. So we're going to have a 2 left here. 2 times 3 is 6. So we're going to have 6 times, you have x squared times x squared, that's x to the 4, but one of the x's have been taken out, so now you have x to the 3rd. And all of that x cubed plus 1 to the 3rd has already been taken out, so nothing to worry about there. And there's a plus in the middle. From the second group, we already took the 2x out. We already took 3 of those quantities, x cubed plus 1 to the 3rd. So you're left with x cubed plus 1 to the 1st power. And if we simplify that last quantity, we will get 2x times x cubed plus 1 to the 3rd times combine 6x cubed plus 7x cubed as, 6x cubed plus 1x cubed as 7x cubed plus 1. And you could use parentheses, you could brackets just to separate as a group. Okay, so that's another example using the product rule. Now, what about finding equation of the tangent line? As we have in number 14 here, to f of x equals sine of 2x at the point x equals pi over 8. So we've done equation of tangent line problems in the past. Typically we find the slope by taking the derivative, right? The slope of the tangent line. So here's where you have to differentiate, here's where you have to use the chain rule. So derivative of sine is cosine. So I have here cosine of 2x. Don't forget, by the chain rule, you multiply by the derivative of the inside, so that'll be times 2. So 2 cosine of 2x. And I'd like to know what happens at the point pi over 8. So at the point pi over 8, we're going to have 2 times cosine of 2 times pi over 8. That simplifies the fraction. It'll be pi over 4, right? And cosine of pi over 4 is root 2 over 2. Multiplying with the 2 up front, so we're just going to have square root of 2. This is going to be our slope for the tangent line. And what about the y-coordinate? Let's evaluate it at the point x equals pi over 8. We'll get sine of 2 times pi over 8, or same as sine of pi over 4. So that's also square root of 2 over 2. Remember, pi over 4 is where sine and cosine are equal, right? And now we're ready to put it together. Y minus the y-coordinate of our point equals the slope, which is root 2, times quantity x minus the x-coordinate, which is x minus pi over 8. So that's our equation. And I'm not going to simplify right now, but you can always, if the question says, okay, leave it in y equals mx plus b form, it should be easy. Just multiply by root 2 on the right side and add root 2 over 2 to both sides. Okay, this last question is rather interesting, I think, because it doesn't even tell you what the function is. It just gives you a table of values. And with the table of values, we are asked just to use those to get the derivative of a composition of functions, such as, look at part A in number 15. So w of x is defined as g of h of x. We're supposed to find the derivative of this function at the point 1. I would say before we even look at those values and we'll get, all confused, I think it's easier to first write down what the derivative is, and then we can go back and pick from the table whatever we need, okay? So let's do that. So the derivative of the w function will be, because it's a composite function, use the chain rule. So take the derivative of the outside, leaving the inside the same. Multiply that by the derivative of the inside. So here I have g prime of h of x times h prime of x. Now remembering that we want to do this at the point 1, so I want to know what is w prime of 1. Again, I'm not going to go to the table yet, okay? So first I'm going to do g prime of h of 1 times h prime of 1. And now I'm going to go to the table. So at this point, I'm going to find what is the innermost value here. What is h of 1? So here's h, here's 1, so here's x equals 1. So h of 1 is 3. So now you have g prime of 3 times, also let's find out what is h prime of 1? That's 5. But we have one last step. What is g prime of 3? G prime of 3. That's 6. So it's going to be 6 times 5, and that's 30. I like these questions because it really checks the understanding of the chain rule, the essence of it, without relying to any memorized algebraic formulas. So if you just remember that, when you have compositions of two functions, you differentiate the outside one, leaving the inside the same, and multiply that with the derivative of the inside. That's exactly what I did over there. Okay, how about part B? We have g of x cubed, and we're supposed to find the derivative of this function at the point 1. Once again, we're going to use the chain rule. So the derivative of the given function equals so differentiate the outside one first, leaving inside the same. So g prime of x cubed times the derivative of the inside, which is 3x squared. Next, I need to find g prime, I need to find the derivative at the point 1. So everywhere you see an x, go ahead and plug in a 1. You're going to have g prime of 1 to the third times 3 times 1 to the second. So that's the same as g prime of 1 times 3. And what do we know about g prime of 1? So we're looking at g prime at the point 1, that's 0. So our final answer is going to be 0 times 3, which is also 0. Again, at this point, I would highly recommend that you try part C and come back and check your answers after you're done. And part C, we're going to find the derivative of h of x to the third power. So the derivative equals, since the power of 3 is on the outside of everything, so I'm going to bring it down, leave h of x the same, to 1 less power of 2, times the derivative of the inside, so h prime of x. And we're supposed to do this at 1, so it's going to be 3 times h of 1 to the second times h prime of 1. And now I can go to the table. So what do we know about h of 1? That it is 3. So it's going to be 3 times 3 squared times h prime of 1. So h prime of 1, that is 5. So we have 3 times 9, or 27, times 5. And that will be 135.